All right, so we're working in section 1.3. We're looking at trigonometric functions of any angle. Let me just remind you where we were, because you probably haven't looked at this since you left last time, which is fine. But we had defined our trig functions, sine, cosine, tangent, cosecant, secant, and cotangent, to be in reference to the triangle. We set it up as a triangle anyway. And we talked about the sides x and y, and then our radius for our hypotenuse here as being r is the square root of x squared plus y squared. And we set up all of these ratios that were y over r and x over y and different ones like this. And so we had done some examples where we were given an ordered pair. We talked about what happens at quadrantal angles. Those are the ones where they're on the quadrants themselves, and how it doesn't really matter how far away you are from the origin because there's a zero present somehow. It's either in the numerator or it's in the denominator, or the numerator and denominator match, since they're both 5 on this example, and so they cancel each other out. So the value doesn't actually change no matter where you are on the quadrantal angle. And we ended up right here where we were taking a look at the non-quadrantal angles, like the spaces of the actual quadrants. So in quadrant 1, all of our trig functions are positive. In quadrant 2, only sine and its reciprocal are positive. Quadrant 3 is tangent, and quadrant 4 is cosine. And each of them have their reciprocals that go with us. And we had an acronym, a SMART trig class, to help remember which one is where. So we're going to be given an example number 3 then, some information that just tell us about the sign. So they tell us that the sign of each of sine and cosine are either positives or negatives, and we decide based on that information which quadrant or quadrants would actually match that information. So this one actually tells us that the sine value is negative and that the cosine value is positive. So you can start with either one of them. I usually start with the things that are positive because I have an acronym, right? And the acronym was a SMART trig class. So if I'm taking a look at a SMART trig class and I'm looking at the values where cosine is positive, well, all of them are positive in quadrant 1 and cosine is positive in quadrant 4. So I'm in either quadrants 1 or 4, and maybe both, depending on what other information I'm given. The other information, though, that I'm given actually tells me about sine. And the sine information that I'm given is that the sine value is negative. So I'm looking at between quadrants 1 and 4. Is sine negative in one of those quadrants? It is. Which quadrant is sine negative in? Yeah, and the one that has the C in it, which is quadrant 4, right? Down there in the bottom right-hand corner. So this is actually happening in quadrant 4. Okay, so there's not really any work you have to show, but at the very least, this is the image that you're thinking about when you're making the decision about which quadrant you're in. You don't necessarily need to show that image unless it's just helpful for you to write it down, but it is the image you should be thinking of. Any questions on that? You might be wondering, well, do I have to start with where the cosine value is positive? And of course, the answer is no. You could start by taking a look at where is sine negative. Okay, well, sine is negative on the bottom half of the picture. And then going from there, you could look at which of those two has a positive cosine. That would be another way of doing that. Okay, let's take a look at another example, example number 4. They're wanting us to find the exact value of the remaining trig functions, and they're telling us we're in quadrant 4. So we've had some questions like this before. Some of the ones that we've had before actually give us like 2 values, like they'd give us cosine and sine, or cosine and tangent, and then we'd work from there. This one gives us 2 pieces of information, but it's not 2 trig values. It's just 1 trig value and the quadrant. It is very helpful to draw the image so that you can get the quadrant identified and drawn in the right place for your triangle. So if I'm in quadrant 4, we just looked at something in quadrant 4, we're down here. And we're going to draw a triangle in quadrant 4. Now, every time we draw a triangle, it starts at the origin and it extends out. And the triangle goes back to the positive x-axis, or negative. It goes back to the x-axis anyway. So in other words, we're never drawing the triangle like this. Or we're never drawing the triangle like this, right? That's never how they're drawn. They're always drawn exactly the same way. We use the origin for the first ray out, and then we go back to the x-axis when we draw the other part of our triangle in, okay? So then the angle is always talking about, so they're using theta here, is always talking about the central angle, the one that's in the middle by the origin. That's always my angle. So as I'm looking at that, it tells me that the cosine value is positive 4 over 5. So it makes sense that it's positive. Quadrant 4, we're positive for cosine values, so that's good news. So when we're thinking about either x's over y's and cosines are opposites over adjacents, things like that, we can think about, we'll still do it what we're doing in this section, but if you want to think about this as the cosine like SOHCAHTOA, you certainly can. We're working with tangent, so we'd be in this case. If we want to use what we had done before, which let me flip back over here to show you, or to remind you, whoops, there it was. The cosine value is x over r. You can think about it from here. All right, so I'm going to use the x over r idea on this one. So this is that the cosine of theta is x over r. And that's my 4 over my 5. So it tells me my x value is 4. Well, the x value is on the x-axis. And the r value is 5. And the r value is always the diagonal piece or the hypotenuse. So here's my 5. Okay. Again, if you want to think of it as adjacent over hypotenuse, it'll put them in the same locations, just different perspectives. Okay, is that okay? So we're supposed to find the other 5 trig functions. Now, one of them you can get without doing any kind of picture whatsoever. It's really straightforward and easy. Which other trig function is the easy one when you're given cosine? Secant. Why is secant easy? Yeah, it's the flip. It's the reciprocal. So I get that one almost for free, right? So secant of theta is what? Yeah, it's 5 over 4. So we get that one. We need a couple others, though. We need sine and its reciprocal, and then we need tangent and its reciprocal. And doing so for any of those involves finding the third side of this triangle. How can I find the third side of this triangle? Yeah, we can use the Pythagorean theorem, which is what Lydia is describing up here. A squared plus b squared is equal to c squared. You may, looking at the numbers we're given, 4 and 5 here, know already what the third side is. This is a special case triangle. It's called a Pythagorean triple when it works out like this. But in general, you won't. So let's just go through this as though the numbers weren't quite so friendly and see what will happen. So my a squared can be the 4 squared. You can put the 4 in either the a spot or the b spot, doesn't matter. And then your c is 5. All right, so 4 squared is 16, 5 squared is 25. And if I subtract my 16, what will I get? Close, try again. Should be 9, right? For the b squared. Okay, so it should be 9. And we actually are going to be taking a square root. Now, when we have seen these before, we've talked about the fact that it's a plus or a minus, and we've sort of ignored the minus because we weren't in an ordered pair location, like we weren't in the coordinate plane yet. We are in the coordinate plane now, so it really is going to have a possibility of being a negative. So I'm going to jot that down. We need to decide, is it positive or is it negative based on its location? Is the y value, right, that lower value down, is it positive or is it negative? This one's negative. Okay, so if you're working in my math lab and you're getting an error, but you're pretty sure you did your math right, you might check your signs. It's an easy mistake to make, right? Okay, so we have our third side. That allows us to find the remaining trig functions. Again, you can either use SOHCAHTOA, or you can use the x's and y's and r's like we looked at the beginning of this section. And we have 2 more pairs to find. We have the sine of theta and its reciprocal, and then we have the tangent of theta and its reciprocal. So using the pieces that are here, sine of theta should be y over r, and y is the negative 3, and the r is 5. And then which one's the reciprocal of sine? Cosecant, good. So what will the cosecant be? You got it, 5 over negative 3. Okay, especially when there's no radicals, those flips are really nice. How about tangent? Well, tangent's either opposite over adjacent or it's y over x. So what do we have for tangent? -3/4. Very good. And then its reciprocal, which would be cotangent, would be what? Yep, 4/-3. We're putting the -3 like in the bottom as the negative, but the negative can be in the bottom and the top and front. It really doesn't matter where we set the negative sign itself. So feel free to adjust where that location is. It's the same value. Okay, any questions on that? Okay, so 3 is a really nice value. A 3, 4, 5 triangle is called a Pythagorean triple because they're all whole numbers. There are a few of those that show up. They're the exception, not the norm. So don't expect to get whole numbers. Most of the time you won't. Like that's just not going to happen. But on this one, it worked out pretty nicely. Okay. Okay, that center angle that we keep talking about. We've only seen so far angles that are small values, in particular acute angles, actually. We've only been looking at angles that are small. But not all angles are small. So sometimes you have angles that are large. Maybe they're like 170 degrees. Or maybe they're much larger, like 910 degrees, right? Well, reference angles can help us manipulate that to being able to be something that's easier to work with. So a reference angle is an angle that is the positive acute angle formed by the terminal side of theta and the x-axis. I promise I'll show you pictures. Let's just get the details written down first, okay? So in general, let me just draw a general picture for the moment, and then we'll give some actual examples later. If they gave you an angle that puts you at, I mentioned 170 degrees. Let's just go over here. We'll do that. 170 degrees would be over here. Looks like that. The reference angle would actually be right here. It takes that terminal side and it goes to the nearest x-axis. So it may be the x-axis above it, maybe the x-axis below it, it may be to the right, to the left. It's just whichever one's the closest. And it creates an acute angle. So for example, if this one had been 170, what would the angle over here on the left be in the yellow? Yeah, it'd be 10. So how'd you get 10? Yeah, it has to equal 180. So I'm going to give you some pictures here in a minute. But what I really think is the easiest thing to do, generally speaking, is to draw yourself a picture to figure out, am I adding something? Am I subtracting something? How much am I adding and subtracting? Because the picture actually tells you a lot, right? You looked at this picture and said, well, I can see that that's 10 degrees. But if I just said 170 and hadn't drawn a picture, you might have been trying to figure out, well, like, do I subtract 180? Do I add 180? Where do I go from here? And a picture actually speaks a lot into this situation. So here are the general guidelines for what to do. And I'm going to give them to you, but then I'm not really going to utilize them all that much because, again, I think the picture is more helpful. So if the angle is less than 360, draw the sketch. Then you're going to actually use the sketch to go back to the nearest x-axis. That's what we did on the last one. If the angle is more than 360, you're going to find a positive angle that's coterminal with the given angle. So in particular, what it usually means is that you subtract 360 however many times you need to until you have a number that's smaller than 360. Okay, so if the number were 910, we'd subtract 360 and we'd be like, oop, that's still bigger than 360, and we'd do it again, and we would get an angle at some point that's between 0 and 360. And then we're able to do exactly what we did in step 1. Okay? So let's take a look at some examples. I'm sorry, a couple of you are still writing. Let me slow down just a touch. Okay, so these are the three we're going to look at. I wanted to start out with degrees because we still feel a little bit more comfortable, I'm sure, with degrees than we do with radians. The first one you notice kind of is in that first case. It's smaller than 360. And that second one is bigger than 360. And the third one, number 7 on the screen here, is not only in radians, but it's also negative, which has a little bit of a nuance to it as well that's different, okay? So let's think what happens for the 205. So it's within 0 to 360. So my practice would be to draw the 205 angle. So which quadrant will we be in if we're at 205 degrees? Yeah, we're in quadrant 3. Very good. So we're down here, and we're at something like this. So all the way over to here is 205. Okay, does that make sense so far? So if I take that angle, right, that diagonal line that I've drawn, and then I make a triangle back to the positive x-axis, I'm sorry, not positive, excuse me, the nearest x-axis, keep saying that wrong, I'd be drawing a triangle here, correct? Do you see the reference angle in that triangle? So it should be right here in the middle. Okay? So this is the angle we're talking about, the one that I've labeled theta prime. This angle out here is the original angle I was given, theta, 205. How in the world can I find theta prime from this picture? Yeah, we're going to subtract 180. So what is 205 minus 180? It is 25. Picture's worth 1,000 words here. Maybe not 1,000, but quite a few. It's very helpful. Now, if I've started with an angle that's bigger than 360 to start with, the first thing I need to do really is subtract 360 and keep doing so until I have a number that's less than 360. Still positive, but less than 360. So then, what is 535 minus 360? 175. It's awfully similar to the one I already did back on the previous slide. So which quadrant will I be in if I'm in 175? Yeah, the second. And we'll be somewhere over here. And this right here is the theta. And it's 175. Now, I should mention what in the world really is the 535. Well, 535 is actually me going around the circle the whole way and then going back to here. That's what it is. And you might sit here and think, well, that seems silly. What would you do that with? Well, you guys see it in sports a lot. Think about some of the extreme sports as a really good example. Some of the skateboarding tricks and some of the bicycle tricks that people do. And they talk about doing a 360 or they talk about doing, a 720 or something like that, right? 2 spins around. You see it in diving as well, some of the Olympic sports. So these angle measures being really large have very practical applications, but they feel kind of funny when we draw them on a picture, okay? So I'm going to take this part off again because it's a little bit easier to see the picture without that piece. But if I take the terminal side that I drew that's over there in quadrant 2, and I extend it back down to the nearest x-axis, my triangle would be here, right? Which means that the reference angle I'm looking for is right here in the middle. So what would I need to do to find theta prime? Yeah, so this time instead of doing my angle minus 180, I'm going to do 180 minus the angle 175. And if I do that, I get 5 degrees. So I think if you look in if you go to the textbook and look through this stuff, or if you go out online and look for ways to do this, they're going to give you lots of formulas. I don't like to overburden myself or you with formulas when I can see a picture and just know what I'm supposed to do visually. So that is my default sort of mechanism. If you're thinking, I don't really like pictures and that doesn't make as much sense to me, when you go find some formulas, feel free to do so. Just look up this topic and you'll find some formulas that give you some sort of flow charty kind of things. If it does this, do this. If it does this, do this, and it'll guide you that way too. Okay, on number 7. So truthfully, if you wanted to turn this into degrees, you could. That's an option. We're not going to do that this way, but it is an option. The reason we're not going to is because when you get to the end of the problem, it needs to be turned back into radians. And I feel like that's a lot of work to change it in and out of degrees and radians twice. So we're going to leave it in terms of radians. Now, if it's negative, kind of like if it's bigger than the 360 to start with, we're just going to keep adding 2 pi to it until it's not negative. Sound good? I want to figure out what the positive value is, or at least something that's smaller than 13 over 6 if I can, maybe. But positive values tend to make a lot more sense in our heads. So I'm going to add 2 pi. Now, 2 pi does not conveniently add to that, but I can get it to have a common denominator, then it will. So what would be the common denominator that I would need here? Yeah, 6. So if I take this and I add, I'd be adding 12 pi over 6. What does that give me? Negative pi over 6. Now I can add another 12 pi over 6 if I want to. Totally feel free to do that if you'd like. But negative pi over 6 is a small enough value that I might kind of have an idea of where that is at this point and not need to change it to the positive value right now. So let me show you what I mean by that. So if I were at pi over 6, which quadrant would I be in? I'd be in 1. So remember, positive angles go clockwise. So we start at the positive x-axis and we go clockwise. So if I've got a negative angle, I'm going to go counterclockwise. So instead of going up and into quadrant 1, I'm going to go down and into quadrant 2. I'm sorry, quadrant 4. Let's get the right number there. Does that make sense? So instead of going up, I'm going to go down. And I'm going to be right here-ish. So down here, this is, and technically what I really did, again, I'll draw it this time, is I really did this, right? That's what negative 13 pi over 6 is. But it's the same as going down to here because we've added the 12 pi over 6, or the 2 pi. And so this theta is actually negative pi over 6. Now, let me extend this so that I have some space to draw some more. If I draw this triangle now back to the positive, or in this case it is a positive x-axis, but the nearest x-axis, that angle is actually the angle I'm looking for. But reference angles are supposed to be positive, right? This is actually equivalent to the positive angle theta prime that's pi over 6. So in this case, I didn't need to add 180 or pi. I added the 2 pi just to move it around to get it to be a smaller number. But it actually sort of looks like I take the negative away. But I don't take the negative away in all cases. It doesn't always work like that. If I had had a negative angle that put me over here in quadrant 3, for example, like if it went negative pi over 3, that would be over here. Negative pi over 3 would be, let's do negative 3 pi over 4. Negative 3 pi over 4 would be over here, right? I wouldn't just say it's 3 pi over 4, right? That's not the value because that's not what I would take to get me back up here. So the picture indicates what we would need to do to find that value. All right, so we're going to use some reference angles now to make some decisions. So this one says, these examples say that we're going to use reference angles, which means we have to find the reference angles, to find the exact value of each expression. It says do not use your calculator. In particular, you can check it with your calculator, obviously. A lot of the time you end up with radicals and your calculator doesn't really help you anyway in terms of giving the exact answer back. So, okay, 405. 405 is like number 6. It's a number that's bigger than 360. So what did we do first on number 6? Yep, we subtracted 360. So I'm taking my 405 and I'm subtracting 360 as my start. And what does that give me? 45. Now, 45 is a very nice angle. We've actually talked about the angle 45, and we'll talk about it more in section 1.4 here in a moment. 45 degrees. Where am I? Which quadrant if I'm at 45 degrees? 1. Yeah, I'm in quadrant 1. In fact, I'm very nicely halfway because it's halfway between 0 and 90, right? And then here's my 45 degrees. And if I form the triangle, it would come down here. And we had a 45, 45, 90 triangle back in section, I think it was 1.2, where we saw that triangle show up. And with a 45, 45, 90 triangle, it actually had side lengths that were 1 and 1 and square root of 2. Does that look familiar? Yeah? Okay. So if I'm looking for the tangent value here, then the tangent value of the 405 is the same as the tangent value of 45 because we used the reference angle. And the tangent value of 45 for this triangle, right, because it's a 45, 45, 90 triangle, opposite over adjacent, x over y, it's 1 over 1. So the tangent value is 1. This is a good example of one that your calculator would be able to check very nicely for you. If you put in tangent 405 and you're in degree mode, right, it's going to spit back out at you 1, and you can check that. You're not going to have the work to support it, so you're not going to get much credit for the problem, but you can definitely check and make sure that you did it right if you're just looking to check. Cool? All right. Next one then. Not so friendly looking value, 23 pi over 4. 23 pi over 4 is definitely a large value. I mean, 405 was bigger than it should have been, right? Bigger than between 0 and 360. So we're going to start with the 23 pi over 4 and try to reduce it. So do you remember how we did that when we were doing, well, in this case, we're trying to eliminate the negative on the last one on this slide. What did we do? What did we add? We added 2 pi. So adding 2 pi would make it bigger, which is what we wanted because that one was negative. This one's positive, so we won't want to add 2 pi. We're going to subtract 2 pi. So we're going to subtract 2 pi, but again, 2 pi over 1, we need a common denominator, which would be what? Yeah, 4. All right, so we're going to take 23 pi over 4, and we're going to subtract 8 pi over 4. Okay, so what does that give us? What's 23 minus 8? 15, lovely. That's still pretty large. So I'm going to make a word of caution. Here's what you should not do. So do not write down what I'm about to write down. Like literally, if you write it in your notes, then I don't know that you marked it out and told yourself this is bad to do, okay? You do not do this. And I want to explain why. What equals means is that what comes before the equals is what is equal to what comes after the equals. And these two statements are not equal. Are you with me? What you're really meaning more is, and the next step is, right? That's what we really mean a lot of times when we put that sort of equals, 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 and we keep doing something like that. So you have a couple options. If you would like, you can do an arrow, and then you can subtract off the 8 pi over 4. I'm good with that. Or just start over again down here. 15 pi minus 8 pi over 4. I know it's a little bit more writing, but it's mathematically correct. So if I take 7 pi over 4 and I subtract 8 pi over 4, I'm sorry, if I take 15 pi over 4 and I subtract 8 pi over 4, I have 7 pi over 4, right? That's actually one of our unit circle values. We're going to learn about the unit circle a little bit later, but it's between 0 and 2 pi. So I can actually stop there and at least give me a picture of where I am. Do you know where we are if we're at 7 pi over 4? Yeah, we're in quadrant 4. So we are down here somewhere-ish, right? Somewhere in there. And this piece got us all the way over. This is 7 pi over 4. And reference angles tell me I want to go back up to the nearest x-axis, which is here. How now can I find this theta prime? How do I get that value? Minus pi isn't quite right, but you're close. It's not pi over 2. Also close. 2 pi. Okay, so instead of, you can subtract 2 pi if you want. But what we really are going to do is we're going to do 2 pi, which would be all the way around, right? All the way around is 2 pi. And then we're going to subtract the 7 pi over 4 that we already had. If you subtract 2 pi, it's not a problem. You're just going to get a negative, and then you're going to remember, I don't need to worry about the negative because I'm in the right place. It'll be fine. But what we really have here is we really have, over here, I'll do it. 2 pi now minus my 7 pi over 4. And then we just discussed a little bit before that 2 pi is 8 pi over 4. So 8 pi over 4 minus 7 pi over 4 is pi over 4. So this one is pi over 4. Pi over 4 is that what I had? Yeah. Pi over 4 is that same 45, 45, 90 triangle that we had actually in the previous example. But we want to pay attention to where we are, namely the quadrant we're in. The last time we were in quadrant 1, so we kind of we got a lot of things for free. Everything's positive in quadrant 1. It's very nice. Not everything's positive in quadrant 4, right? So in general, 45, 45, 90, or these pi over 4 values would look like this. That's what they look like in general. But we do have a sign that we have to actually add in somewhere. Which one of these values is negative? Which one? Which now value of 1? Do you know?
What?
Somebody said 1, I thought.
I said y.
Y. Yeah, so it's the y value or the one that's in the y location, right? So this one right here, the y value, the one that comes down, sorry, I misheard, is the negative, right? It's the one that drops down. Okay, so as we're taking a look at that, depending on the trig value that we're looking for, this one's for cosine, it will matter. I want to make sure that the negative goes in the right place. If I put it in the wrong place, I might get the wrong sign on my answer. Cosine should be the x though, right? So cosine of my angle, so it started out as 23 pi, keep leaving the 3 off, 23 pi over 4, which is going to be the same as the cosine of pi over 4. Well, negative pi over 4, and then, how do I want to write that? I think I just don't want to write it is what I want to do. I think I want to just write my x's and y's there. Let's do that. We've drawn the picture, which is what we needed. So it should be x over r. That's what we'll write. So what is the x value? Not looking at the angle, the x value of my triangle. So in my triangle, my x value is 1. What's my r value? The square root of 2. And then based on what we did last time, you know what to do with that square root of 2, right? Yeah, we're going to rationalize. So we're going to multiply by square root of 2 on top and bottom. And the answer is going to end up giving me square root 2 over 2. And it's positive. If I had been dealing with sine here instead of cosine, it'd be negative, because I'd be using the y value, which, like Chloe said, is a negative value on this one. Okay, so we do want to pay attention to those signs. Sometimes you can sort of not pay attention to them and turns out okay, but sometimes it won't. So just pay attention as you go. Any questions on those? All right.